So today we're going to learn how to construct an isosceles triangle in GeoGebra, and we're going to use what we know about triangles and circles to do this. So first, what do we know about isosceles triangles? Well, we know that isosceles triangles have two congruent sides, so this differs from an equilateral triangle where all sides are congruent, but on this specific triangle, only two of the three sides are going to be congruent. And we also know that the perpendicular bisector of the base goes through the vertices, connecting the two congruent sides. So what that means is that the perpendicular bisector of the very base of the triangle, when you create that, you're going to see that it goes directly through the vertice that connects the two congruent sides. And we'll see that more later. But now let's jump in and get started. So the easiest way to create an isosceles triangle in GeoGebra is by simply making a circle. So that's what we're going to do. You click on the circle with the center tool and you make a point. So what we know about circles is that the distance from the center to any point on the circle is going to be congruent. So we're going to make a segment from A to B, and now this segment is essentially the radius of the circle. But again, we know that if we make another radius at any point in the circle, it's going to be congruent to AB. So we're going to make another segment, and you can choose any point on the circle. I'm just going to choose my point here. And now we're going to connect these 2 points here to give us our isosceles triangle. Now we see that if I move this point anywhere on the circle, I'm going to have an isosceles triangle because this segment AC and AB are going to be congruent. And if you just want to see the triangle, you can do the show hide object and you can click on your circle and then you are left with your triangle like such. So now the other way that we can do this using the perpendicular bisector, we're going to create another circle. So you'll click on your circle tool again and create a circle like so. And here we are going to make another line segment, but instead of this being one of our congruent sides, we're actually going to make this the base of our triangle here. So what you would do is you would come to the perpendicular bisector tool and you're going to click it. And so this perpendicular bisector is created. And what a perpendicular bisector is it essentially, it bisects the segment and then creates 90-degree angles on both sides. So that is a perpendicular bisector. And what you're going to do now is you're going to create a point at the intersect as I find the intersection tool. So you're going to click on the circle and you're going to click on the line. And you see that it intersects at 2 points here. So you can choose either of those points that you like. I'm just going to stick with point D here. And you're going to take segments and you're going to extend them like so. And from what we know about isosceles triangles, that the perpendicular bisector goes through the vertice connecting the two congruent sides, we know that the segments AD and BD are going to be congruent. So here we can move this point anywhere, this point B anywhere on the triangle, and we're still going to have our equilateral triangle like so. So these are just a few ways that you can create this equilateral triangle. And again, you can show and hide things. So you can hide the line, you can hide the circle. And when you click back on your mouse tool, you'll see that you still have this triangle that you can play around and move with. But again, there's many different ways that you can do this. I implore you to get on GeoGebra and play around, try to come up with a new way to do it as well on your own. But these are just some good ways to get started. Tomorrow we will be learning how to construct an equilateral triangle. So this is just a good way to get started and to see what tools we have. So be thinking for our assignment tomorrow on how we can create an equilateral triangle in GeoGebra instead.